So this guy is called Newton's Cradle. Maybe you've seen him before on the desks of people. It's kind of a common toy, but there's a lot of fun physics behind it. Now, I'm not going to get into too much detail in the physics, but let's have a little bit of fun and let's be scientists. What's a scientist? Asking questions and discovering the answers yourself. So here we go. So first of all, Newton's Cradle, named after Sir Isaac Newton, who among many others did a lot of great experiments and discoveries and has written some theories and laws about physics. One of them being an energy, that energy cannot be created or destroyed. It can only change forms. So Newton's Cradle basically demonstrates the principle of the law of conservation of momentum in energy. So this contraption has usually 5 spheres. Mine has 7, hanging just so that they're barely touching. These spheres are metal, and as they touch, they all kind of move together and they're swinging. So when we talk about energy, there's 2 kinds of energy I want to first talk about. The first is called potential energy. Potential energy, say that. That's called stored up energy. For instance, if I take one of the spheres right here and I lift it up just so, I'm about to drop it. But right now there's some stored up energy. Energy that's ready to go. We call it potential energy. Potential energy. Now, if I let it go, it becomes energy in motion. The word for that is kinetic energy. Now, when I drop it, the question is, where will the energy go? And what will result as the energy changes? So the energy is going to change, but remember, it can't be lost or destroyed. So where do you think it'll go? What do you think will happen? Make your predictions now. I'm going to drop one sphere. What do you think is going to happen to the rest of the Newton's Cradle contraption? What do you think? Okay, well, let's find out. Let's see. Let's observe. Dropping 1, potential energy here, and go. Okay, you see what happens? The energy transfers through each of the spheres, and all that energy is stored up, and guess what? It pushes this one, and now it's got potential energy, and goes off and comes back, and it goes back the other way. And it goes that way on and on. Now, it eventually slows down because of the air around us, and air has friction. So, but if this were in a vacuum, it would go on indefinitely. It would go on forever, just back and forth, because the energy can't be lost or gained. It can only change, and it just changes from one sphere to the next. Pretty fun. Let's try something else. Let's try 2 spheres. Based on what we just talked about, what would happen if I dropped 2 spheres? Make your prediction. Okay, let's see what happens. 2 come up. So the same amount of energy. It's the law of conservation of momentum and energy. So 2 marbles or 2 spheres causes 2 to... Let's try 3. You can probably see where I'm going with this. 3 come up. Can you see it? What about 4? Here, I'm going to drop 4 of the 7 spheres. Where do you think is going to happen? I only have 3 on this side. What do you think? Okay, maybe. Well, let's observe and find out. Dropping 4 spheres on Newton's Cradle. 3, 2, 1. Do you see what happened? I dropped 4. How many came back up on the other side? 4. Yeah, even though there was only 3, the sphere in the middle joined that side and it came back up. And so this guy, he got to play on both teams there. He was back and forth on both teams. So let's try 5. Dropping 5. What do you think? If I drop 5, how many will bounce up on the other side? All right, let's see. All right. Now that energy transfers through the spheres. All right. But what if I have 2 spheres dropping at the same time from both sides? They'll come together. That energy will come. What do you think is going to happen? It'll explode. Let's find out. Are you ready? We're going to drop them at the same time. Let's see. 3, 2, 1. even though the energy's going both ways, it transfers through and the momentum hasn't changed and it pushes off. It's just a little bit faster. If I do one at a time, or one each side, even if I do two, the transfer of the energy of two spheres transfers over. Two. Let's try three. That's my favorite right there. Newton's Cradle, a lot of fun, a lot more energy, discussion about what's going on here. There's even some more physics that you can get into and read about. But keep discovering, have some fun.